So this is January 2011 AS1 paper. And we're just looking at question 8, a multiple choice question. And if you get a question like this, the first thing you need to do is to write out your neutralization equation. So it's all about sulfuric acid being neutralized by potassium hydroxide solution. So we're used to really writing our alkali first, so our metal hydroxide first, so we will do that. So potassium hydroxide, if you need to do your swap and drop, then do that. Potassium is group 1, so it has a valency of 1. Hydroxide, its charge is minus, and so it has a valency of 1 as well. So if we swap and drop that, we can see that we've got KOH plus sulfuric acid, which is H2SO4, is going to react in a neutralization reaction to give us potassium sulfate. Again, we need to do our swap and drop. Potassium is in group 1. Sulfate has a charge of 2 minus, so its valency is 2. Swap and drop that, we get K2SO4 plus water. Because here we've got a metal hydroxide reacting with an acid. So metal hydroxide plus acid gives us a salt plus water. Or you can think of it as a neutralization reaction is obviously an acid plus an alkali giving us a salt plus water. Okay, so the problem with our equation here is that it's not balanced. You can see I have 2 potassiums on the right hand side, for example. So I need to put a 2 in front of my potassium hydroxide, and now that's balanced in terms of my potassiums, but then I need to put a 2 in front of my water to balance my hydrogens and my oxygens. Okay, so in order to work this out, we need to do a moles calculation. So we have 50 centimeters cubed of 0.2 moles per decimeter cubed sulfuric acid. Okay, so we have a volume and we have a concentration. So we need to use the equation N equals CV. So our concentration is 0.2 moles per decimeter cubed, and our volume is 50 centimeters cubed, which is 0.05 decimeters cubed. And that gives us a number of moles of 0.01 moles. So that's how many moles of sulfuric acid I have. So to work out how many moles of potassium hydroxide I need to exactly neutralize it, I bring that over to the potassium hydroxide in the equation. But looking at the ratio of our balancing numbers, we can see that the ratio is 2 to 1. And that means I need to have twice as many moles of potassium hydroxide. So I've got 0.02 moles of potassium hydroxide. At this stage you have a couple of different options. The first option is to go through your multiple choice and work out your number of moles and find out which of these volumes and concentrations gives you the number of moles of 0.02 moles. So to do that, I will be using N equals CV for all of these options for answers. So for option A, I've got a concentration of 0.4 and a volume of 100 centimeters cubed, which is 0.1 moles, and that gives us 0.04 moles. So that's not our answer. For option B, I have a concentration of 0.2 times by 0.025 decimeters cubed, which gives me 0.005 moles. So again, that's not right. Option C is a concentration of 0.2 times by a volume of 0.05, which gives us 0.01 moles, so again not right. And then finally option D, concentration of 0.2 times by volume of 0.1, which gives us a number of moles of 0.02 moles. So that's one option, you can do it that way. That's probably the more logical, methodical way of doing it. Another way of doing it is looking to see, we've only got 2 concentrations of potassium hydroxide solution. So you could take your number of moles of potassium hydroxide and rearrange the equation, your N equals CV equation, to give you volume equals number of moles over concentration, and put your desired number of moles, so 0.02, over the 2 different concentrations, and work out of what volume of potassium hydroxide you would need for that concentration and see if that matches any of the options. So let's start with our first concentration of 0.4. So 0.02 over 0.4 gives you a volume of 0.05 decimeters cubed, which is 50 centimeters cubed. So what's that saying is, if I have a concentration of 0.4 molar potassium hydroxide, I would need 50 centimeters cubed, but you can see option A, it gives us 100 centimeters cubed, so that can't be right. So I'll just rub that out to give myself a bit of room. Okay, so the next option I have is a concentration of 0.2 molars. So again, volume equals my desired number of moles, 0.02, over my concentration, which is 0.2, which gives me a volume of 0.1 decimeters cubed, which is 100 centimeters cubed. So if I'm using a concentration of potassium hydroxide of 0.2 moles per decimeter cubed, that means I need 100 centimeters cubed of it, and you can see that that matches up to option D. But I think the first option is probably more logical, and work through your answers that way. It just means you have to work it out for each and every option until you get to the right one. And in this case, it's option D. So looking at the question, you might have thought that, well, I have 50 centimeters cubed of 0.2 sulfuric acid, and so you might have been drawn to option C, 50 centimeters cubed of potassium hydroxide, but it's because of this ratio here that we need 2 moles of potassium hydroxide to completely neutralise 1 mole of sulfuric acid. And why is that? Well, it's because when potassium hydroxide is in solution, so dissolves in water, I get potassium plus and 1 hydroxide ion because of the formula of it being KOH. But when sulfuric acid dissolves in water, so when we have a solution of sulfuric acid, you can see that I have 2 H plus ions for every 1 mole of sulfuric acid. So we know that neutralization is an H plus ion reacting with an OH minus ion, a hydroxide ion, to give me water. That's your ionic equation for neutralization. So here you can see that with sulfuric acid I've got 2 hydrogen ions to neutralize, but for every 1 mole of potassium hydroxide ion, I only have 1 mole of hydroxide ions. So that means I need 2 moles of potassium hydroxide for every 1 mole of sulfuric acid. So going back to the options for the question, I'm going to need a number of moles that is twice that of the number of moles of sulfuric acid because of that ratio. So if you get a question like this, just be careful. Your first step is always to write out your equation, your neutralization equation, and balance it first of all. Say for example this had been hydrochloric acid, it would have been a 1-to-1 ratio between your alkali and your acid, and so it would have been the same number of moles you were looking for. But you need to write out that equation to see your ratio.